Good day, learners. Welcome to Technical Mathematics lesson. My name is Mathule Latakhomu. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Grade 11, our topic today is functions and graphs. So let's look at our lesson objectives. At the end of this lesson, learners will be able to sketch and determine the equation of exponential function, and also you have to sketch and determine the equation of a circle, and the third one, it will be interpretation of graphs. So now let's look at our exponential function. We know that the equation of our exponential function is given by y is equal to b to the exponent of x plus q. Then we're now looking into the effect of b on our graphs. So we're saying if b is greater than 1 and b it can be 1. So numbers that you see as or numbers that are greater than 1, we know that is numbers like 2, 3, 4 going up. Those are the numbers that are greater than 1. So the shape of our graph, you know that when we read the function from the left to the right, we can see that the graph now is going up. Then we call it an increasing function. We're saying there our function is increasing. That's when b is greater than 1, which means that the number that is carrying x is greater than 1. So we can have it like y is equal to 3 to the exponent of x. That's when you have your graph increasing because 3 is greater than 1. But then if b is between 0 and 1, b is greater than 0 but less than 1, and also b it can be 1, then there you will see that our function, it is now going down. Correct? Then we have it as decreasing function. Our function there, it means it's a decreasing function. We can see on this one that the number that is carrying x is 1 over 2, which is 0.5, and is between 0 and 1. So now, when we're looking into our function, we have also what we call an asymptote. Then the equation of an asymptote is y is equal to the value of q. So any value of q that you have there, it will be your asymptote. Then when we put it as an equation of an asymptote, it's y is equal to the value of q. So those are the golden rules of our exponential function. Then now, let's look at how do we sketch this particular function. So the first thing that you need to know is to identify your asymptote. Then your equation of your asymptote is y is equal to, in this case, the value of q is negative 3. So that is going to be your asymptote. So that is the first thing that we need to look for. Then the second thing that we can look for, we have your y intercept. We know that where x is equal to 0. So what does it mean here? It means when we're looking for your y intercept, the value of x needs to be 0. Let's remove the bracket. Then we have -2, -3. Then if you punch it in your calculator, you will see that it will be -2. Then as a coordinate is going to be 0 and -2. That's what you have as your coordinate. Then when you have your asymptote y-intercept, then we're looking for our x-intercept. So our x-intercept, the value of y is equal to 0 there. Correct? So the value of y is equal to 0. Then what do we say? We say 0 is equal to 2 to the exponent of x minus 3. Then we have to make x the subject of the formula. The first thing that I will do is to transpose my -3 to the right hand side. So we're going to have 3 is equal to 2 to the exponent of x. Now that you realize that in this case our bases are not the same, then we will introduce the logs both sides. Then when you introduce the log, we now apply the laws of logs to saying that exponent now we can make it, or we can multiply it with our coefficient. Then you're going to have log 3 of 2 of x log 2, sorry, of x log 2. Then we divide both sides by log 2 and log 2, so that log 2 will divide log 2. Therefore, x will be equal to. Then when you punch it in your calculator, you just say log 2 or log 3 divided by log 2. Then you have your answer there as 1,6. So now it means you have 1,6 and 0 as your point there. So now when you have your asymptote, y-intercept and x-intercept, we then do what? We sketch our function. The first thing that we're going to start with there is to identify our asymptote, which is y is equal to -3. That is your horizontal asymptote. Y is equal to -3. Then we now need to sketch our graphs. We're looking into our intercept. It's -2. Y is -2. That is your x and y. So in this case, y is -2 and x is 1,6. 1,6, somewhere there. Then in this case, you will know that the value of b is greater than 1, which means our function is an increasing function. Our function there, it will be an increasing function. So that is your function of y is equal to 2 to the exponent of x minus 3. Then you will have your domain and your range. We know that the domain of your exponential function is x is element of all real numbers, because for each and every x value that you substitute in your function, you will get the y value. Then now, we're saying range. We're looking at where the function is defined on the y values. So since we have our asymptote there at -3, it means y it can be -3 or below -3. So now we will have y as greater than -3, because the graph is defined when y is greater than -3. So that's how you get your domain and range, and how you also sketch your function there. I hope it's clear. Let's look at the second one, where our function now is y is equal to 1/4 to the exponent of x minus 2. Always, you will be required to determine the equation of the asymptote. Remember, y is equal to the value of q, which is -2. Then from there, you will still get your y-intercept. X is equal to 0. Then y is equal to 1/4 to the exponent of 0 minus 2. Then y is going to be -1. So you are going to get 0 and -1. Okay? So now, x-intercept y is equal to 0. In this case, we are having 0 equal to 1/4 to the exponent of x minus 2. We apply the very same method. We take -2, we transpose it, we are going to get +2 is equal to 1/4 to the exponent of x. So in this case, we can say 2 is equal to 1/2 to the exponent of 2. Correct? We know that that is the prime factor of 4. In this case, now we want to make our bases to be the same. So we are going to have 2 is equal to 2 minus 2 as your exponent there. 2 to the exponent of -2 x. So it means that we are going to have 2 is equal to 2 to the -2x. And remember that the exponent of our 2 on our right hand side is 1. So now when we have the same base, we do what? We equate the exponent. 1 is equal to negative 2x. Then we divide by negative 2. We divide by negative 2. Negative 2 will cancel negative 2, therefore they divide each other. Therefore, x is equal to negative 1 over 2. So that's basically how you are going to get your x-intercept. Correct? So it's different from the previous one, because on the previous one we didn't have the same base. Hence we had to introduce the logs. Correct? Now, when you have your asymptote, y-intercept and x-intercept, we can then sketch our function. So we start with our asymptote, which is negative 2. Then we are going to get, or to indicate, our asymptote there. Y is equal to negative 2. Then we go back and look for what? Look for our asymptote. X is 1 over negative 1 over 2 and y is negative 1. You have your y and your x. Remember, the point there is 0 and negative 2. On the other side is negative 1 over 2 and 0. Those are the 2 points there. But now, since our value of b is between 0 and negative 1, then our graph will be a decreasing function. Will be a decreasing function. Then in that case, we know that we can have still our domain where x is element of all real numbers, and our range when y is greater than negative 2. So basically that's how we are going to get our range and domain and how to sketch our function. So I hope it is clear that when you sketch your exponential function, you need to identify your asymptote, your x-intercept, and y-intercept. Sometimes I know that you can use your motherboard method, which is a table. It's also allowed. Okay, so moving forward, we have two things: how to sketch a function and also how to determine the equation. So now, we were given a function, we sketched the graph. Then now we are given the graph, we need to determine the equation. So now, looking at our question, it says we must determine the equation of y is equal to b to the exponent of x plus q, which is your equation of your exponential equation. Then looking at our graph there are two things that are key and that you need to look for always when you determine the equation of exponential. The first key thing is your asymptote. The equation of an asymptote, which is 2, therefore in this case it tells you that your q is equal to 2. Your q is equal to 2. And we also have another key thing, it's your point, at least on that graph. One point on that graph, which is 1 and 6. Then you know that in this case we are having x and y. So when we substitute in our equation, y is equal to b to the exponent of x plus q, which is 2. Remember, q, we already have it. So now your y is 6 and your x is 1 plus 2. Now we need to make b the subject of the formula. I will transpose this 2 to the other side. Is going to be 6 minus 4 is equal to b. Therefore, b is equal to, that is 2. Therefore, b is equal to 4. Because b to the exponent of 1 is still b. Therefore, your equation is y is equal to 4 to the exponent of x plus 2. That's how you get your equation. Simple. You identify your asymptote. Then you need 1 point from your graph. Then you can calculate for your value of b, or the value that is carrying x. Okay. So now it makes sense that our value of b is 4 because our function there, it is increasing. We can see that we have an increasing function. Okay. Let's look at another one. Very same equation that we need to determine. So with this one, because we have seen how we determine the equation of an exponential function, I will give you at least 2 minutes to determine it. Then I will do it with you. Just take 2 minutes and determine this equation. Okay? Now, let's look at how do we determine this equation of an exponential. Remember, I spoke about the key things that you need to look for on our graph. It's 1 point on that exponential equation and also your asymptote. So now, the value of q in this case is equal to -1. Therefore, you will have y is equal to b to the exponent of x minus 1. Then 1 point that we are looking for is -1 and 2 on your graph. Then we do have x and y. So now your y is 2. B we don't know, but x is -1 minus 1. So now we need to put or make b the subject of the formula. So what do? We still transpose that -1 to the right hand side. We're going to have 2 plus 1 is equal to. Now, your b, we can write it as a positive exponent, which is 1 over b. So, 2 plus 1 is 3, 1 over b. We need to now make b the subject of the formula. We can divide here by 1 and cross multiply. We're going to have 3b is equal to 1 because 1 multiplied by 1 is 1. Then we divide by 3. We divide by 3. 3 will divide 3. Therefore, b is equal to 1 over 3. That means the equation is 1 over 3 x minus 1. That's how you determine your equation. So it's as easy as ABC. So that's what we needed to do. That's how you sketch and determine your equation of your exponential function. Now, equation of a circle. We now look into our equation of a circle. We start with your full circle. This equation can be given in two ways. The first way is x squared plus y squared is equal to r squared. And remember, always the center is at origin in technical maths. So our center will always be at 0 and 0 in technical mathematics. So always when you draw your equation, when you draw your circle, the equation, the center is at origin. Or you can put it in terms of y, which is y is equal to plus minus the square root of r squared minus x squared. So that is also the equation of a full circle. Correct? So now we know that we have our radius. Correct? Which will be equal from all the sides. Correct? Those lines there will be equal because of your radius. Now, we have also equation of your circle in a semicircle. Remember, you can have a full circle or have a semicircle. With a semicircle, now, remember, we had y is equal to plus minus the square root of r squared minus x squared. We're saying this one is your full circle. But now, semicircle, we have also two equations. The one with y equal to plus square root of x squared minus, r squared minus x squared. Then the other one is y is equal to negative square root of r squared minus x squared. So there are two semicircles there, which makes a full circle. So the one with positive, you will see it above your x-axis. Then the one with a negative, you will see coming below your x-axis. So there are two semicircles. One is above x-axis, one is below x-axis. Joining them together, we have a full circle. So those are the dynamics that you need to know about this equation. So now, let's look at how do we sketch this function now. Remember, we have x squared plus y squared is equal to r squared. In this case, we know that the value of r squared is equal to 9. So how do we then get our radius? We are going to introduce the square root, both sides. Then your radius will be 3. Now, when you sketch, always your center is at origin. Your radius will go to positive 3 on x, positive 3 on y, and 3 and negative 3. That is the radius. Remember, radius is always counted in positive units. So now, sketching the circle, you will just draw your circle. It won't be that accurate, but you will have the picture of how to sketch that equation of your circle. Correct. So now, on this circle, you can also have a question that asks about the domain and range. Remember, the domain and range is where the function is defined. The graph is defined. So we can see that on your domain, talking about x values, domain, remember, is x values and range is y values. On your x values, where does the function start and where does the function end? The function starts from -3 and 3. So that's where the function is defined. From -2, 3 to 3. At -4, you don't have a function. At 4, you don't have a function. So the function there is specific. So it's x element of -3 to +3. We use square bracket because 3 and -3 are included in that function. So that's how we determine the domain. The range, we do the same. Y values. This function is defined on the y values from this -3 to that +3. So the y values are defined between those lines there. Those values, sorry. So your domain, your range is the same. Y is element of -3 to +3. So that's basically how you get your domain and range on this function. Correct? So we go and look into the next one. So with this one now, we now have to sketch, correct, that function of a semicircle. Correct. Remember, we have y equal to, there it is positive, r squared minus x squared. So in this case, that 16 there, it represents our r squared. So we introduce the square root both sides. Our r is going to be 4. Because there it's positive, it means it will be +4 on the y values, -4 and 4. So our semicircle will look like something like that. That's how our semicircle will look like. Right? So now, domain and range. Those domain and range, always in the exam, you will be asked, you need to know how to read your graph. So with your domain, talking about x values, we can see that we're starting at -4, we ended at +4. So your domain, x element of -4 to +4. And we use square bracket because -4 and 4 are included in that function. Yes, please. Okay. Now, let's look at the range. The range, this graph now, we don't have it as a full circle. It means now it starts at 0. This graph starts to be defined at 0 because that point there is 4 and 0, and the other one is negative 4 and 0. Then now, it means the y values, they start from where? 0. Going up. But where do they end? They end at 4. So the graph is defined from 0 to 4. Hence now your range will be y is element of 0 to 4. Y is element of 0 to 4. So that's basically how you then determine your range and domain on your semicircle. Okay? So now, the next one that we have is y equal to negative square root of 4 minus x squared. Y equal to negative square root of r squared minus x squared. It's a semicircle. Then in this case, 4 is representing our r squared. So introduce the square root. Your r will be 2, which is your radius. Then because we have a negative there, it will come below. So those are the points where our graph, from where? From origin. So you will draw your semicircle. That's how your semicircle will look like. Then we now have to determine our domain, x values, and the range, y values. And the domain and range on this graph, remember, domain is where the x values are defined. X element of negative 2 to positive 2. But with y, you can see that now we're having it at negative 2 to 0, because the point there is 2 and 0, negative 2 and 0, and 0 and negative 2. So range is y element of negative 2 to 0. From negative 2 up until 0. So that's basically what you need to know about this function, semicircle. Simple and straightforward. Okay. Now we have sketched our full circle, the semicircle that has a positive y value and the one that has a negative y value. Then now, let's go and find out how do we then determine the equation of these circles. Okay, we're now looking at our sketch. Always center is at the origin, 0 and 0. For us to determine our equation, we need to know what is the value of r squared. Then we have a point there, which is a root 3 and 1. What do we see there? X and y. Then our equation there, it's x, which is square root of 3 squared, plus y, which is 1 squared, it's equal to r squared. We're going to have 3 plus 1 equal to r squared. Therefore, r squared is equal to 4. In this case, we know what is our r squared now. The equation is x plus y squared is equal to 4. In this case, 1 mark will be for your substitution and 1 mark will be for your equation. So normally they can give you 2 marks to determine this type of equation. Correct substitution and your equation. Okay. Let's look at the interpretation of graphs. So, good people, when you interpret the graphs, in each and every question paper of graphs, you are going to find some questions that has the following symbols. Whether you call it symbols or you call it equations, but you will have something like this. F of x equal to g of x, f of x greater than g of x, f of x less than g of x, or we said f of x multiplied by g of x is greater than 0. So in this case, we know that when they are talking about f of x, all these things, they are what? They are y values. All of them are y values. That's the first thing that you need to know. That f of x is the same as y value, and g of x is the same as the y value, because we can say y is equal to 2x plus 1. And I say f of x is equal to 2x plus 1. So these things, they are the same. Whether I write it as y or I write it as f of x, they mean the same thing. So now, the question will come in a way of, for which values of x will the graphs be equal, where the y values of these graphs are equal? Correct. So because here we're talking about the equal y values on this first one. What is the value of x where g of x and f of x have equal y values? For instance, I will make an example. If you have a graph like that, we call it a parabola, right? So on our parabola, let's say it's facing downwards. Then we have our straight line coming like that. Correct. So we then say our turning point is 0 and 9, right? And our x-intercept, let's say this side is maybe -3 and 3. Suppose that we have something like that. So in this case, we are saying, where are the y values equal? Correct. This graph, x and y, we can see that these graphs are equal where? They are equal when y is equal to 9 and where y is equal to 0. But what are the x values in those points? What are the x values in those points? X values are what? Where y is equal to 9, they are equal. Your x is equal to 0. Or where y values are 0, your x is equal to 3, because the point there is 3 and 0. So it means this point, y values are equal where? At 9 and at 0. But on those points, what are your x values? At 9, the x value is what? 0. At 3, the x value is what? At 0, sorry, the x value is what? 3. So those are the x values where the graphs, the y values of those functions are equal. So, and this, we call it interpretations of functions. They carry 2 marks, sometimes 3, sometimes 4, but learners need to understand how to interpret or how to read the graphs. Correct. So now, let's look at now, using the very same function, let's look at the second one. I will use a different color. Here, they are saying, f of x, let's call our red one f of x, and let's call our straight line g of x. Right? So, where f of x, the red graph, is greater than g of x, the black one, straight line. So greater, it means where it's the graph of f, the y values of the graph of f are on top of the y values of the graph of g. Looking at this function, we can see that at this point here, that is the only time the red one is on top of the black one. At that point. So we can see that the red is at the top, the black is at the bottom. But what are we looking for? We are looking at the value of x. We are not interested in those y values. The answer must be in terms of the value of x. And looking at the value of x, you can see that it's from 0 to 3. So, how are you going to write it? We are going to say 0 greater than x, x greater than 0, but less than 3. That's where the y value of a red graph on top of a is greater than the y value of the black graph. F of x is greater than g of x. From where? From 0 to 3. Only there. So, this type of questions, they are not difficult. You just need to know how to read your graph as a learner. So now we can do the third one. We can see now that we want where the y values of g of x, which is a straight line, the black graph, is on top of the y value of the red one. So you can see that the black one here is at the top of the red one. Correct? So those values, they're starting from 0 going to the left, the x values. We don't know where they are ending, but they start from 0 going to your left. And on the other side, it's where? It's at 3 going to the right. That's where now the black one is on top of the red one. So now, it means you are going to say x let's put it properly. We're saying x is less than -3. -0, sorry, not -3. -0, because we're saying they start at 0. X is less than 0. From where x is less than 0, that's where the black graph is on top of the red one. Then, from 3 going that side, that's where now the red one, the black one is on top of the red one. Where x is greater than 3. So you can see that from 0 to 3, those values of x are not included because the black one is below the red one. So that's basically how you read or interpret those functions there. And it applies in all the functions, not only straight line and parabola. All the functions, that's how you read it. So now, let's look at our questions. Because basically in the exam, these are some of the styles of asking the questions. We give you a graph and we start asking you questions. Okay. We're saying, consider the diagram alongside. The graph of f of x, which is equal to y, equal to negative x squared plus 4. And g of x is equal to y is equal to x minus 2. Those are the two graphs. You can see that we have a straight line and we also have your quadratic or parabolic function. So we have determined the following: the coordinate of A and B, the coordinate of D, for which values of x. Now, you can see there at number 3 that for which values of x will f of x multiplied by g of x less than 0, then f of x divided by g of x will be undefined. Then those are the conditions, and that's where now we need to interpret our graphs. Then, how do we do that? The first one, simple. They just want us to calculate for the coordinate of A and B. You can see that coordinate of A and coordinate of B on your parabola, which is this graph here. A and B are the x-axis, which is x-intercept. Basically, we're going to say x-intercept, y is equal to 0. If y is 0, negative x squared plus 4, we are going to transpose and get x squared plus 4. Introduce the square root there. X will be plus minus 2, which means A is negative 2 and 0, B is 2 and 0. That's how you only need to do x and y intercept. The value of D, you can see that D is at the y value of your straight line. Then it means you say y-intercept, but x is equal to 0. But in this case, we are talking about the straight line, not parabola, but the straight line, which is what? Y equal to 0 minus 2. So y is equal to minus 2. Therefore, D is 0 and minus 2. Then you get your full marks. When we mark here, you will then say 1 mark for letting y 0, and we now give you the coordinate. 1 mark for letting x 0 and give you the coordinate. So you will find that this one is 3 and that one is 2. Correct. Then now, we know our values. -2 and 2 and -2. The turning point, we know that it will be at 4 there. So now, we are having this. Remember, it's the same as y multiplied by y less than 0. And the minute you see less than 0, we're talking about negative values. Let's write it properly. Negative values. Negative values. So, in this case, what do we say? We are saying, what are the conditions of y values? That when I say y multiplied by y value of f multiplied by y values of g, that will give me negative values. Remember, I'm talking about the values of y. We want the x values where, when I multiply these y values, I get what? Negative. It's when you have positive multiplied by negative, you will get negative. Or negative multiplied by positive, you will get negative. What do I mean? If you have on the graph of f, which is your hyperbola, this graph is the graph of f. That one is the graph of g. So if the y values of g of f are positive and multiplied by the y values of g that are negative, then we are going to satisfy the conditions that is less than 0 there. Correct? Then if the y values of f are negative multiplied by the y values of g that are positive, we will then satisfy the condition of less than 0 because we will be getting negative values. But now, using colors to interpret that, on the graph of our parabola, those y values are negative, but at the top there they are positive. The y values are positive there. They are positive. Up until b, then they start to become negative. What I'm indicating there is the y values of the graph of f. Below 8 going to your left, they are negative, and above a going to your right, they are positive. Up until b. Then from b going to your right, they are then negative. So now, the one for your straight line, they are negative there. Negative, 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 negative. But from b, they start to be what? Positive. We are talking about the y values. That graph will go up until there. So now, where do we then satisfy these conditions? Which condition? X, which is, y that is positive multiplied by the one that is negative. So we have intervals there. We have the first interval, and we have another interval there. Correct? How many intervals do we have? 1, 2, and 3. On the first interval, we can see that there we have negative multiplied by negative, which will give you positive. I'm talking about multiplying the green and the blue. Correct. Where x is equal to negative 2. That interval there is out. That one, the first interval is out because we want, where we multiply those values of y, we get positive. So on the second interval, we have positive multiplied by negative, which gives us negative. Then from negative 2 to 2, that interval is satisfying our condition there. Then, the third interval, we have positive blue multiplied by negative green. We're having negative. So, for also that third interval, it is correct. So, basically, we can say from negative 2 going to your positive x infinity, all those values of x, they satisfy the condition that we are looking for. So in that case, we're going to basically say x is greater than negative 2. Where x is greater than negative 2, then this condition is met. It's as simple as that. And that's how you interpret your graphs. 2.3, what does it say? Undefined. It's when you do what? It's when you divide by 0. When you divide by 0, that's where you get undefined. So now, where the y value of g is 0, this whole thing here, it will be undefined. And the y value of g is 0 where? At x is equal to 2. That value of b is 2 and 0. Y value is 0 there. So, x, this value will be defined where x is what? X is equal to 2. Because the point there of b is 2 and 0. So that's basically how you answer this type of questions. It's very simple to answer. I hope you got that one. Moving forward, we have another activity there, the very same approach of interpreting. So below, sketched below are graphs of f and g defined by f of x is equal to negative square root of r squared minus x squared, and g is equal to 2x plus minus 10, respectively. A, 3 and negative 4 and c are the points of intersections of f and g. B and D are the y-intercepts of f and g respectively. We can see our sketch there. The question is to determine the coordinate of C, to determine the length of BD, the equation of f, and the values of x for which. Now we have another condition there. Do we see the interpretation where it comes in? So now, let's go back. We know the information of our graph of G, which is the straight line. The straight line, we're saying G of x is equal to 2x minus 10. And they say we must look for the coordinate of C. Coordinate of C, you can see that it's at the x-axis. So the only thing to do is x-intercept. Your y will be 0. Then, if your y is 0, what will be the value of x? 2x minus 10, negative 2x minus 10. Remember, what I just did there was to transpose this one to the right-hand side. We divide by negative 2, we divide by negative 2. Therefore, x will be positive 5. It means the coordinate of C is 5 and 0. C is 5 and 0. Simple. So basically we know that if C is 5, that it will be negative 5 and that it will be negative 10. But B there is going to be negative 5. Why am I saying negative 10 at D? D is the y-intercept. So y-intercept x is equal to 0. So y is equal to 2 of 0 minus 10. Then y is negative 10. But for B, we know that is minus 5 because of the radius there. Then the length of BD, you can see that from negative 5 to negative 10 is 5 units. So DB is 5 units, the distance there. It's 5 units. Simple as ABC. You only need to know how to interpret your graphs. Okay. The equation of f. Remember we have 5, negative 5, negative 5, negative 10. On that equation, we know that here is 5 and 0, 0 and negative 5, 5 and 0. So we take 1 point because remember, our function, it was given as follows. What we need is the radius. So it's y is equal to negative, radius is 5 squared minus x squared. Therefore, our equation is negative square root of 25 minus x squared. That's basically what you need to do. If you know your radius, you are done. Then now comes the question there. G of x minus f of x greater than 0. So, for us now to answer this type of a question, basically we can just take this one and transpose it. Then it will be g of x greater than f of x. Then you know we have g of x and f of x. Remember, we want where the y values of g are greater than the y values of f. And we have the graph of g and the graph of f. In this case, we look at this part here. The graph of g is on top of the graph of f where? From that point of C to that point of A. The shaded part there of a straight line. That is the only part where g of x is on top of f of x. It means the y values of g from A to C are on top of the y values of f from A to C. Then you can see from B to A, the f is on top of the g. So now, the y value there is 3. It means that y value there, the x value there, x is equal to 3. It means x is 3 from there to 5. It means x from 3 to 5. That is the only part where the graph of g is on top of the graph of f. So your answer there is going to be between 3 and 5. X values that are between 3 and 5 makes the y value of g to be on top of the y value of f. And that's your answer. I hope that one was clear as well. And this is the end of the lesson. I hope you enjoyed this lesson. So go back, get some previous question papers and practice. Thank you. Okay. Sibahle, you can ask. Open your mic and ask.
No, it's fine, so I understand.
Oh, which part did you get confused on?
The last part, the one that you were doing right now.
Oh, the one of for which values of g, okay, for which values of x is g of x greater than f of x? I didn't change the question. Remember the question says g of x minus f of x, right?
Yes.
So for us to make our life simple, we will take that f of x and put it that side so that it can become positive. G of x can be greater than f of x.
Then f of x.
So that it will be easier for us to interpret it in that way. You see it? Yeah, it means the same thing, correct?
Okay, I know, I understand.
Okay, no, thank you.
I shut up.
Sharp. Okay, so in the absence of any other questions, then let's call it a day. Thank you.